All right. Hello, everybody. I would say welcome back, but I'm the only one that was gone anywhere. Thank you for your patience last week. The exam went okay? Maybe? Yes? Kinda? Okay, we'll talk more about it. I actually have a few makeup exams to schedule. If that applies to you, I will be emailing you probably shortly after this class, so by the end of the day with some times. Okay, so you enjoyed the guest lecture, Caleb? He's pretty great. He said you guys were a little more engaged than he did this once for me last year, so he was kind of feeling like you guys were asking some good questions and things, so appreciate that. Always nice, probably encouraging for him to feel like you guys were getting something out of it. So I'm a little biased, but I think he's got some pretty interesting research going on, so glad that he was able to share that with you. Okay, so today, kind of just looking back on where we are, we're going to cover the Flint water crisis. So today's topic is going to be a nice tie-in for everything we've covered to date, especially kind of the disinfection kind of stuff. Given the way it kind of set up the semester, I figured even though this could be done before the second exam, it'll kind of be a little recap of that category. It just made sense to do it this way, I thought. Then we'll get into wastewater. It's funny because the course title says wastewater on like the flow chart. It's technically water and wastewater treatment, so it didn't really, I mean, it may have lied to you a little bit, but we'll get to wastewater treatment. And as I've said, disinfection applies to wastewater, so does sedimentation, so does a lot of what we've been talking about. So, but we'll focus directly on wastewater. After today's seminar type lecture, will be pretty much the rest of the semester will be more wastewater focused. Told you before, but the final exam will be somewhat comprehensive about, if I were to measure it in problems, and let's imagine I gave you 3 problems to solve, or let's say 4. 1 would be from exam 1 would be from exam 2, and then 2 from the wastewater section. Okay, but I'll probably do like I have been, keep it pretty similar in scope, some multiple choice type of questions, and the majority of that, or maybe half of that, would focus on the wastewater topics. Okay, with that said, I do plan to do one more quiz type activity on the Flint water crisis. So you did that once with the cryptosporidium stuff, had a bit of a reading assignment. This one will be similar. It will be just a Moodle quiz, time limited. And what I'll have you do is reflect on what you learned today. And what I hope today will do for you is just kind of pique your curiosity. And then with that curiosity, you're welcome to take a look at some other things. And the task that I will give you is really to click on 2 links and read a paragraph of each, essentially. So I've got 2 readings here, plus an extra lecture. We'll talk a little more about Mark Edwards. If you wanted to see some more perspective, maybe a little bit more about how things went with the discovery of lead and the EPA side of things and some controversies, that one is a pretty interesting one. These 2 papers, they are on the Flint water crisis. We'll talk about them in the lecture in a minute. But what I'd like you to do is just take a look to see how much you can get out of the abstract. And if you're getting curious, go take a look at the conclusions too, right? Guide it with your curiosity, but take a look at both is what I'm asking you to do. So there's 2 readings. They're both scientific articles. Anytime you're dealing with a scientific article, look is the assignment. But I'm not expecting or asking you to read every last bit. So, but give yourself a chance to get curious if you find yourself curious, and there's some good resources there. All right. Otherwise, today's lecture should probably equip you fine for the quiz. All right. Okay. Any questions on that? All right. And today's lecture will be a little bit seminar style. You'll see it's not quite solving problems. It's a little more of a look at, I guess, ethics and kind of, navigating engineering in the context of society, right? So that what I hope you're getting from this is a little bit of a little more of an, ethical or societal civics type of framework. So I actually have to begin, and a lot of what we'll talk about today is sort of the timeline of how things happened, what the story is for the Flint water crises. And I say crises, there's actually technically a couple of them. There we go. And so we're going to talk about the lead, which is the obvious one that you've probably heard about. Anybody never hear about the Flint water crisis? Okay, so I'm getting old, is what I can tell. It used to be in the news a lot. Happened, I guess 11 years ago now, and 10 years ago it was like in full swing. And so I need to tell you a little bit about myself, and I was not quite a part of it, but I was near it in some ways. And so the big thing was there was lead in the drinking water, and a big controversy about that. That's the one most people have heard about, but it turns out there was a couple other issues involved, one being a Legionnaire's disease outbreak. Talk more about that. And otherwise, simply the disinfection process when the Flint water crisis began. So I finished my PhD in 2014. I also got engaged at the beginning of 2014. I then got married towards the end of 2014, and I moved to Michigan. So I did a lot that year. It was a big year. I moved to Lansing. That's not too far from Flint, and my then wife, divorced now, we moved to Michigan because she had a position in the Michigan's Department of Health and Human Services as an epidemiologist. So she was kind of involved, as you'll see, in some of these pieces, and I'm actually borrowing some of her slides that I've used since that time. So turns out I ended up working at DEQ starting in 2015, Michigan's Department of Environmental Quality. My expertise to that point was kind of drinking water. Turns out I couldn't find any drinking water jobs. I could only find something in wastewater, and I'm very glad because I wasn't formally involved with any of the controversies. Backwards. You'll say, okay, Lansing's here, Grand Rapids over here, and blah, blah, blah. And so Michigan's a fun place. It's very cold, needed an entire new wardrobe coming from Atlanta. But there I was. Okay, so what's the timeline for the Flint water crisis then? Well, we actually have to go back quite a ways. Turns out that we put lead pipes in the ground some time ago. Probably starting whenever we started putting pipes in the ground. And even the Romans, the word lead, if you look on the periodic table, the label for it is Pb. Why is that? Well, that's coming from the lead, the root word for plumber that we use. So in Latin, it's something like plumber. Okay, I don't remember the actual Latin word, but that's where we get plumber. That's where Pb is coming from, because it's just very easy to use lead, to shape it, to mold it, to make it watertight, and to have a metal pipe that's going to last a long time. So since, 1900 or so, we were using lead in pipes. It turns out, as we'll talk about, that there's some obvious risks there, whether it's the pipes themselves made of lead or joints and connection pieces. Some obvious risks because lead turns out to be a strong neurotoxin, and it's a bioaccumulatory, so it's really hard to get rid of once you have it. And especially for children, it's going to mess up neurodevelopment. So there's some serious issues of having lead in your water. However, it's actually also the case that it's potentially okay to have lead in the pipe so long as you're doing everything else correct to prevent that lead from coming off of the pipes. That'll be a big theme today. It's not actually the case that lead is always a risk. It means if you have lead in the pipes, there is a risk, but if you manage your distribution and your water quality properly, maybe it's fine. okay? Even though there's still a risk. So there's going to be a lot of navigating of, okay, what's the best thing? What's the worst thing? How are we going to deal with this? What's worth the cost to make an intervention? I don't know about here locally, but there's a very good chance there's lead pipes in some places in Baton Rouge, New Orleans, kind of all over the country. So keep that in mind, but as you'll see, it just gives us more incentive to do the water treatment steps and management properly. Okay, so we have lead in the ground. All right, next up, we have to understand a little bit about the history of Flint to understand, and for those of you who don't know, historically, Flint, Michigan is known to be quite impoverished, at least in the past several decades. And to get to the history of that, we want to look back to kind of the 1930s through 60s, where there was a real large boom in industry, the auto industry and especially, in that area, which brought quite a lot of prosperity, a lot of jobs, a lot of wealth, factories, all that. So there's a big boom, but of course, that eventually collapsed. And, of course, you could perhaps consider who to blame or what dynamics or political decisions, any of that. We'll have a lot of that type of potential blame today. I'm not really interested in assigning that blame, but sometimes it's helpful to try to learn from mistakes. Okay, so to whatever caused the auto industry collapse there is essentially what led to what we now know as the Rust Belt. And some of that just could be accidental stuff. Maybe it used to make a lot of sense to ship things into the Great Lakes through the shipping channels, and suddenly maybe that was not the more ideal circumstance, right? Some different things can affect stuff. So anyway, auto industry collapse, that gives us a localized economic depression, and so the city of Flint in particular was hard hit. I think a lot of Michigan was, and a lot of the so-called Rust Belt. You lose a lot of jobs. Your population, therefore, if you can move, you probably do move for better opportunities, and people who are left were the ones who couldn't afford to move, perhaps, and don't have very good opportunities anymore, right? So it's a very difficult situation, and a kind of a long-lasting impact. So in the early 2000s, 2001 to 2010 range, it got so bad that the state of Michigan, which had been trying to help compensate for these economic issues, they had been trying to support Flint and other cities that were really in economic hardship. And I don't know exactly when they started, but it's sometime probably around the 70s or something. They decided they had to stop revenue sharing. It was time to force these cities to balance their budgets themselves. So in 2001 and 2010 range, the state government stopped this revenue sharing program where they would take revenue from, let's say, Grand Rapids, which was doing a little better, and share it around to Flint and other cities. Now, there's a lot you could argue here about whether or not it's fair. On the one hand, you could say that's not fair to stop. Why are you not helping anymore? We have serious needs here. Our infrastructure, our water, all that is really important. On the other hand, maybe you could argue that, hey, it's not fair to take my money for your problems. And that's kind of what they were doing on a city type of level. So again, not here to state which one is correct or better or whatever, but that's what decision was made. And I think those were the difficult dynamics that were essentially tried to be balanced there. So that causes Flint to have an extremely difficult situation, such that they were defaulting on their financial, obligations. So in 2011, the state appoints emergency managers, or begins appointing emergency managers, to make financial decisions on behalf of the city of Flint. There's probably some other cities that this happened to as well. We're going to focus on Flint. And so these emergency managers were not elected. They were state appointed, and they were I think at 1-year appointments, sometimes they wouldn't even serve the full year or would be cycled out or something. And so it's kind of up to the state governor, whoever he or she decides would be a good emergency manager would be tasked to do it. So they might not be from Flint, probably not, and they might not have any idea of like what's going on, probably don't have any incentive to consider exactly what the residents are interested in, because they're not elected, right? They're not, it's not a representative circumstance. As you'll see, this becomes quite a problem and a big source of the issues. So in 2013, there's an emergency manager, and I think if you really wanted to, you could probably find exactly the names. Wikipedia has a nice little timeline that I got some of this stuff from. You probably find the names and start trying to play the blame game if you really want to, and see the gory drama history of who did what and all that. At any rate, the emergency manager in 2013 decides that switching water sources would be a good way to save some money. Up to that point, they had been taking water from Detroit's water and sewerage department. So Detroit had been taking water, I think, from Lake Huron, treating it, and passing it along the pipes, and it would get to Flint, and they would re-up the disinfectant, do some very rudimentary, simple treatment just because it didn't need much, and then pass it along to their customers in Flint. So that had been the thing, but of course they're paying Detroit for the water, and the emergency manager feels like, well, we have a river, we could just treat our own water, right? Well, that turns out to be a very, very bad decision in all things considered, as we'll see. So also in 2013, bless you, the Detroit Water and Sewerage Department is a little upset that Flint just decides to cancel the contract. Perhaps didn't consult them. I don't know exactly what the drama was, but they decide, okay, well, if that's what you're going to do, you have 1 year until we're going to disconnect you. Okay, so they give them a full year to adapt. That sounds like a lot, but maybe if you have to re-engineer some things, perhaps we could associate some blame or some excessive pressure that Detroit's Water and Sewerage Board was putting on them. I don't know. But there's a 1-year termination notice given, so that means in 2014 they're going to have to switch water supplies. So at that point, Flint, and I think Flint had been planning a larger renovation to take from one of the lakes. You know what I could do? We'll just pull up Google Maps. Just to give you a little, better show of what I'm talking about. Oh, no, stop. So there's Grand Rapids, by the way. Okay. Go away. All right, so here's Lansing. Flint is right here. And they do have a river, but I think they were planning to take a pipeline. There was a project with some of the other cities. And I think they were planning to get water from that pipeline and connect. And it would be a fairly long-term, large investment, but get good water here from Lake Huron. Meanwhile, Detroit has been getting water, maybe it was Lake St. Clair, but essentially, or maybe this channel here from Huron. Detroit, meanwhile, had been getting water and then sending it up, piping it up to Flint. So that's kind of the scheme of what their proposed plan was. Well, they realized that they're not going to have quite enough time to complete all that, given the 1-year notice. So they have to take from the Flint River, which I think is right here. Yeah. So they have a challenge, and they say, well, that's going to take too long. So what are we going to do? And by the way, I should note that the entire plan here was something like we should be able to save over the long haul about $5 million per X amount of time. I think maybe it was over a 10-year window or something like that. Might have even been $5 million per year. Just write that a little more clearly. So maybe 1 year, maybe a few. But their target was to save some money on doing water for themselves. So given that their initial renovation plans were going to take too long, in April 2014, they decide to use the Flint River. And let me do one thing off screen for you here. Forgot. Okay. And that's a questionable decision. Now, it would probably be okay if they properly handled it, but they didn't, which was the real big problem. Turns out the Flint River water is more corrosive. Maybe it's a bit lower pH. Maybe it simply just doesn't have the same buffers in it, not as much phosphate, which is a nice anti-corrosion chemical. It's more corrosive. And the big failure is they do not add corrosion control, which is required. And so Detroit had been adding it. And Flint, when they were adapting their treatment, needed to add it, and it wasn't added. That is truly like the biggest mistake that was made throughout all of this, in terms of the engineering aspect of it. Come back to here. So that's the beginning of the Flint water crisis. I don't know for sure, but it might have been the same day I defended my thesis. No, probably, I think I defended probably a little later. Anyway, so immediately, Flint residents began complaining about their water. It smelled bad. Some cases it looked a little orange. It tasted bad. The people kind of knew there were some issues with this. Now, there is a small bit of reason why you might think that, okay, just changing the water supply, as we talked about in class, there are some aesthetic factors that are not necessarily health related, right? So it might be fair to say if everything was going well and it was safe, it might still put off the residents. Plus, the Flint River has a nasty reputation of being basically a toxic dumping site for a lot of the industry over the years. So it's got a bad reputation. People don't want it. People are upset. This wasn't their decision to make, right? This was that emergency manager. And they probably are already feeling like, hey, why are you doing this to us? That's not cool. So immediately they're complaining. And immediately, a few months later, there was some treatment issues detected. And now this is a treatment issue within their treatment plant. As they're sending water along, they realize they have too many coliforms, meaning bacteria that have not been disinfected. So their disinfection treatment is not sufficient to handle the extra bacteria that are in the water in Michigan in August. It gets a little bit warm, kind of like, I don't know, maybe late October here. It's kind of funny. It was really funny hearing them, Michiganders, complain about the heat and the humidity. And I'm just like, this is neither hot nor humid. What are you talking about? Anyway, and that was before I came to Louisiana. So at any rate, that means they had to issue a boil water advisory, and they had to start upping their chlorine dose. This happened twice in August. And when they did that, well, turns out you can't just overly chlorinate because you can form disinfection byproducts, these trihalomethanes and things. Flint River water also had a fair amount of organics, and now that they do not have the capacity to give the water enough contact time with the chlorine. They just had to up the chlorine dose so high that they were forming the toxic byproducts. So they're in a bad situation. This Flint water treatment plant was not designed for this type of treatment, was not up to par, even though it was approved. So there was some, in addition to the engineering mistake of not adding corrosion control, probably the biggest one, there was also this situation where it literally was not capable of handling the demand that was going to be put on it. So a poor review in terms of deciding whether or not this was capable. And there's a good chance there was some political pressure on whatever engineer that was, so who knows how exactly that went down. But no engineer should sign off on that if it's not sufficient, right? So, got some issues. Pretty much immediately the residents don't like it. Then, as soon as there's any kind of challenge to the system, it's not treating water well enough, so there's boil water advisory, there's disinfection byproducts that they're getting in trouble with. Things are not going so great. Had another thought, lost it. THM is trihalomethanes. It's just one of many halogenated disinfection byproducts. So if you have some organic matter that has some methane groups on them, and you add chlorines to them or bromides or whatever, any halogen, you get these trihalomethanes. You could have trihaloacetic acids, halogenated acetic acids. Bad stuff. Okay, at this time, the Flint city officials are insisting that the water is safe. Now, a couple minutes ago, I reminded us that, well, technically speaking, it can taste bad and be safe. I mean, some of you drink tea and stuff, and people might say that doesn't taste good, but it's safe, right? But the thing is, the city officials were also purchasing bottled water for use in their office. So the what's the word? Not irony exactly, but the hypocrisy is getting pretty thick, right? They are literally ordering lots of bottled water for their city office, and meanwhile telling all the city residents that it's fine, it's safe, drink the water, bathe in the water, use the water, whatever. So that's kind of terrible. And by this point, Flint Water, by December of 2014, the Flint has already spent $4 million on their water treatment plant upgrades to get it to this point where it's almost working, but also poisoning their entire community. So, not a good situation. Really getting close to already over budget for what they were trying to save. Complete disaster, right? This is pretty bad. So, by January 2015, Detroit, their Water and Sewerage Board, I think they might have renamed that, so that might not be the current name, but they realized that Flint's in a hard spot and compassionately offered to reconnect and waive the service fee. Now, that sounds like, oh, okay, cool, I don't have to pay the $200 service fee. That's not exactly what the service fee is entailing. This is actually would require engineering drawings, excavator equipment, and quite a lot of disruption to dig up, reconnect, install new pipe connections, turn off the water at a certain time, turn it back on, flush the system properly. This is a much bigger deal than just switching a valve, because it's they completely disconnected them. This, for all I know, could be $1 million. Right, so this is no simple thing. This is a pretty big task. So that's actually we'll say engineering drawings plus construction, etc. So that's probably a pretty good offer, and probably something that, at least in my books, looks to be a good faith type of thing to say, well, we may have accidentally screwed you over pretty hard there, so here, why don't we help you fix that? So good on them for the offer. But of course, we're stuck with an emergency manager who is perhaps not very capable of managing. And the emergency manager outright, so this is January 2015, outright rejects that offer. Right around this time, I'm receiving a job offer, interviewing for a position at Michigan's Department of Environmental Quality. Just a little aside. By March, the city council votes unanimously to reconnect, to take them up on the offer. Unfortunately, the city council has no real power because it's the emergency manager who vetoes that vote, that desire to reconnect. So to look at it quite pessimistically, this emergency manager is refusing to stop poisoning the Flint residents. Of course, at this point, the full extent of the problems are not known. So it's not exactly that malicious as I'm making it out to be. But in effect, that is what happened, which is terrible. So sometime mid-2015, I think it was probably May or June, there was a pediatrician who recognized in that area that there was an alarming elevation of blood lead levels in children's blood, who were her patients in that area. And this was shocking enough. I forget her name, but you can definitely find it within in some of the literature or the Mark Edwards video. She ends up getting in touch with Mark Edwards, who is a professor at Virginia Tech, environmental engineering, who had worked on some distribution systems and related lead issues in DC and some other things. So he's done a lot of work on corrosion, on lead pipes, on distribution systems. And so she ends up getting in touch with him. And that's when really, shortly thereafter, we really recognize there is a lead problem in the water. So this is when we learn, or the public learns, about the lead in the water. So by October, it was clear enough to everybody that the mistakes were really, really bad. October is when Flint switches back to the Detroit Water and Sewerage water, which did have corrosion control and did have adequate treatment that they had been using for many, many years. So at this point, in some sense, this would be kind of the end of the crisis. At least in the sense of, as soon as you have the opposite of corrosion would be perhaps slow mineralization, letting minerals deposit on the pipes. As soon as you have that happening, instead of taking minerals off the pipes, which will get lead into the water, then you have the situation where it's at least stabilized, and perhaps there's going to be a few pieces that still fall off of the next few days, but in short order, the crisis is over in terms of lead should not be leaching off the pipes anymore. We always want to operate, and maybe I mentioned this before, but we want to operate our distribution systems in a way where instead of corroding away material, we are slowly adding material. So if you've ever had hard water and you see mineral deposits and kind of gunking up your sink or your shower or whatever, we want that to slowly constrict our pipes until we have to replace them, instead of the opposite, which the opposite would be just taking away materials very slowly, but water will eventually erode things, right? Even if it's a very, very small amount dissolving, over many years, you will eventually dissolve the pipe if you're heading in that direction. So very long time, you would get pipes breaking and then letting groundwater, which might be right next to your sewer pipes, which might be leaking a little bit. You don't want that water in your pipes. So we always want to be accumulating rather than corroding. Lead is another big reason why we'd want to do it that way. We never want lead to be released from any piping materials. So that would be effectively the end of the lead crisis and probably the end of, or the beginning of the end of all the crises. By January 2016, I had already, so I worked at DEQ for about 6 months and decided I maybe wanted to occasionally do something else other than shovel paperwork, is what I like to call it. And I decided to try academia again, and I was in a postdoc by that point. So I was at Michigan State University, which is, if you talk to anybody from Michigan, they'll insist, absolutely insist, this is East Lansing. I lived in Lansing, and there's a difference apparently, right? Okay, so if you're anybody from Michigan, anybody know any from Michigan? They're really kind of funny about that. It's like, East Lansing. Okay, anyhow, so the governor finally admits Legionnaire's disease, that there's also this other aspect, this Legionnaire's disease outbreak. So there's been all this controversy, all this discussion of lead, importantly so, but meanwhile, this switch in water treatment and the switch in the water quality and the lack of appropriate treatment has also caused an outbreak in Legionnaire's disease. As we'll talk about, it's a combination of some mismanagement at a particular hospital, some cover-up of that, and in general, just the change in water quality made the systems more vulnerable to that. So we'll talk more about that, but in 2016, they finally recognized that. In the meantime, between then and this next entry, I came here. So I got the job, probably came down here in April 2016 to interview and began here in fall of 2016. So in February 2017, the CDC linked the Flint water to the Legionnaire's outbreak. You might think to yourself, well, this outbreak was actually happening kind of in this time frame. Why is this only in 2017 that we linked it? Well, it turns out that some of the officials in Genesee County were not really doing what the CDC was asking them to do and doing things, they weren't cooperating very well. There was some drama and tension between the state health department and the local health departments there that were pretty problematic. So we'll talk a little more about that in a little bit. But finally, they say, okay, the Flint, the DNA of this Legionella bacteria in the pipes is matching what's in the river and is matching what the patient cases had. And the Legionnaire's outbreak, it might not sound like a big deal. Maybe you haven't heard of it too much. But for anybody that's immunocompromised or elderly, it can be a really severe pneumonia is typically how it presents. And so it actually caused deaths. So caused more deaths than the lead, because lead causes probably more harm if you want to calculate it that way, poisoning children and in a permanent fashion. But literally the Legionella outbreak, Legionnaire's outbreak, was attributed to some deaths. Okay, so from there, it's essentially legal outfall for the most part. So just a quick few highlights here. January 2021, the former governor of Michigan, that would be Rick Snyder, and 8 city officials or other officials were charged with a total of 34 felonies, 2 misdemeanors. 2 officials were charged with involuntary manslaughter. So lots of serious business there, right? Lots of legal trouble. However, the following year, the Michigan Supreme Court ruled that, and I think this was a unanimous ruling, that you can't use one-person grand juries to bring indictments, which is what they were doing for each of those cases. So by the next year, so by I think later in 2022, I think they ended up reversing or dropping those charges. So I don't know exactly whether or not accountability was really found. As I said earlier, that these things are difficult, complicated. I've been here since 2016, so I don't have locals to to hear the drama from either. So I don't know. I think that there was definitely some accountability needed. Obviously, a lot of accountability needed. I don't know if, you know, to what extent the single-person juries, maybe we ought to go back with multiple-person juries for that instead. I don't know the situation, but at least there was quite a lot of legal trouble, so that itself might be some punishment. So I don't know if it's sufficient. Oh, it was 2023, the Michigan judge drops the felony charges. So I think the other charges probably stayed. The felonies were removed. Also in 2023, there was Genesee County Court approved a Flint water settlement here, but I think there was another settlement in 2024. So really the legal outfall continued for some time. And meanwhile, there's also a big effort to replace all of the lead pipes. As I've told you already, that's actually not the real solution. But if you have this type of situation, it probably does make sense, if for no other reason, for the public's benefit and as a gesture to make sure it can never happen again, right? So that does make a fair amount of sense, even if there are other ways to make sure it never happens again. Properly operating your water system, it certainly is something that would be probably worth the cost to do that. And so during this time, they had been replacing pipes. In March 2023, I think that was supposed to be 2024. Sorry. The Flint city officials were actually held in contempt of a court order to achieve complete exchange of these pipes and updates and repair of the sidewalks that were disrupted from it all. They were missing the deadline. I don't think it was by much, because as we'll see earlier this year, they finalized all that, but they were held in contempt. Not sure what all that meant, but that was a legal issue. And this year, the last lead pipe was replaced. So yay for them. Now, one thing I'll comment here is it's actually quite difficult to find the lead pipes sometimes, because this is premise plumbing, meaning you have your main water distribution system. Okay, you probably know where that is. You have your arterials, probably know where those are heading into a neighborhood. But from that to the house, there are many homes with no remaining blueprints. What if the house was built in 1933 and then nobody kept the blueprint, or nobody bothered to write down where the pipes were, or maybe somebody came in and plumbed a new pipe in and didn't update or keep any records. So it actually turns out that replacing all the pipes is a much more complicated and difficult task than you might think. So this was something that I remember years ago people describing the effort to use machine learning to understand what's the most likely location for a pipe in an area, in a neighborhood, which ones are most likely to have lead in them, and so on. So this was a pretty major effort, just recently wrapped up. And that's the timeline of the Flint water crises. Any questions on that part? Any of this surprise you? Not really? Yeah. I think there were people that went to jail. I'm not sure, but I think so.
It seems like a lot of oversight wasn't there. A lot of missing regulations.
Yeah. Yes, lots of cutting corners. And that's where the big problem comes in of having an emergency manager whose job is perhaps in a way to cut corners, but with no repercussion of being held accountable by, because it's not a elected official, right? So then you have to go up to the governor who appointed him or her, and it's like, okay, how are we really getting accountability and the proper repercussions? And yeah.
What kind of background did the managers even have? Like business?
I think sometimes it was business, sometimes it was buddy, sometimes who knows, it's a big part of the problem. Presumably, someone with financial experience, but clearly not water treatment experience. I mean, and you wouldn't necessarily expect them to have water treatment experience, but you would expect that there needs to be these checks to say, no, you can't change that water unless we add this corrosion control, which is going to cost X amount. So there's a chance that was the fault of an engineer who didn't catch that, but there's probably a good chance that there was also an excessive amount of pressure to cut the corners and overlook stuff like that. So I don't know how exactly. Question over here?
So for the Flint's updated system, were there not any state or local set parameters for water treatment that they had to adhere to?
It's a good question. So one of the issues here is there's a lot there. First of all, the water coming out of the treatment plant had no lead in it, right? So there are many standards that a treatment plant has to meet, and many of those are checked as it's sending water out. That's where the trihalomethanes, the coliforms, the bacteria stuff, those were all caught at the discharge. So aside from those parameters that they had to address in August 2014, aside from those ones, the water was safe coming out of the treatment plant. Now, there's also what's called the lead and copper rule, that you have to check a certain number of homes or taps in the distribution system to ensure that there's not lead or copper coming off the pipes. Now, there has been updates to that lead and copper rule because of some of the controversies, how they were doing it. They missed it, obviously. Why did they miss it? Was this negligence? Was it the rule is designed poorly? There was some controversy there, which ultimately there's now a revised lead and copper rule because of that, to make sure that's not going to be missed. I don't know. I think there was some people that suspected that the statistical analysis used for that was cutting corners again, but I'm not sure. I think there was also a coherent argument that said, no, we were doing it right. We were supposed to exclude the outliers, but that would be why we missed it. So I don't recall the exact outcome aside from that rule was definitely revised. And so that's a case where I'm not sure if that official that was doing the lead and copper monitoring was actually doing something wrong, and then jailed for it or anything. But certainly, if they were following the rule properly, it's a very good thing that rule was updated. You have a question?
Do you know if there's still any everlasting environmental impacts from 2011, from when the crisis was seriously? Still lead in people's blood, in Flint City and stuff like that.
Yeah, I don't know. I don't know if lead in your body will stay longer than a certain number of weeks or months. I think your body probably slowly excretes it, as with most things, but the neurological damage is permanent. So for children that were poisoned, yeah, that's the rest of their lives. They're going to be impacted. Environmentally, I'm not sure. I mean, it's pretty disruptive to dig up all those pipes, but grass will grow back. So I'm not sure about environmentally that way. Yeah. Okay. The other thoughts, comments? And we're going to talk more about it. This is the timeline here. Pretty crazy stuff, huh? Okay, so what were the failures, if I had to summarize them? Maybe a good slide to keep in mind for your quiz when you take it. Well, I mentioned repeatedly already, corrosion control. Really, the lack of corrosion control was a big, big deal. And corrosion control is pretty simple. We typically add what's called orthophosphate. That just means we are adding PO4 3-. That's a buffer. Maybe we add it as H2PO4 2- or whatever, but we just add it and we are adding protection. We don't want to add a ton of it. It's not good for the environment to have a ton of it discharged, but a little bit of it goes a long ways and really protects. So from one of these papers you see here in October 2015, this is tap water from the Flint River, no corrosion control. They're checking how much iron, how much gene copies of Legionella there is, and this other pneumonia bacteria. And then 1 year later, not even a full year later, with the Detroit Water Sewage Department water, here's what it looks like. Corrosion control in place, much better water. So clear difference there. Another issue was that inadequate treatment capacity when they did the switch. So that led us to excessive chlorination. Chlorine, by the way, if you didn't know, is fairly corrosive. So when we already have a corrosion control problems, we're adding a bunch of extra chlorine. That's not ideal. The water supply itself was more corrosive. The fact that this wasn't caught and accounted for with corrosion control was the issue. Another thing that I haven't mentioned yet, but maybe we can recall when I was first introducing the status of Flint, there's a lot of empty homes. Given the economic depression, given that the city was kind of built many years ago where there was many people coming in, if you have many residents leave, you end up with vacant homes, which means there are many dead ends for your water to kind of sit and stay, and that's has some interesting implications, because then you have some areas where your water sits for a long time. So then that could have bad effects if that's continuing to corrode. Could have bad effects if some bacteria were able to make it there and now are starting to live and thrive there. That could be a problem. Ultimately, another big deal was that lead and copper rule didn't catch the issues, which now that has formally been revised. Okay, a little bit about the lead and copper rule. So essentially, this is for monitoring at the tap. Ideally, the theory is it will catch and prevent such things as this Flint lead water crisis. So overall, we decide as a society that, health-wise, there is no safe level of exposure to lead for getting it in your body. The LCR, that's like the lead and copper rule, is the acronym. It essentially gives an action level where the 90th percentile of samples must be below 15 parts per billion of lead or 1.3 parts per million of copper. Otherwise, some action is triggered. Now, you'll notice that says the 90th percentile. So it's going to exclude the 10th percentile, some cases in that situation. Now, this was, I think that's the initial setup. Samples were checked semi-annually, so twice a year. And site selection was by likelihood of impact. And there's some big potential for controversies there. Now, of course, you can't sample every tap in the distribution system. Not at all possible. So how do you go about selecting the places that are important to study where it's likely to have some impact? Obviously, you could make bad choices there. You could make choices for bad reasons there. So that's a challenge, and maybe part of the challenge that they faced. So originally, the lead and copper rule was issued in 1991. Recently, the revision is 2021, and that's going to give us some new rules, some new things to do. So now we are aiming to replace 3% of existing lead-containing pipes per year. It used to be 7%, so it's weird that it's going down, but now there's no exceptions. So there used to be some exceptions, okay, if you don't have the blueprints or whatever the case. Now you must, is the rule. So eventually, well, if you take 3% per year, you're going to eventually get close to zero, but never to zero. Kind of kidding. But so that'll give us, over time, a removal of lead pipes throughout our country. Then they were also reviewing and adapting the monitoring protocols, and importantly, adding corrosion control education for operators, for everybody involved with this aspect of the LCR. They also made some improvements. I have it. Sorry, that's probably October 2021. Sorry about that, I'll fix that. Don't worry about it. I'd like that to show. And this would be lead service line inventories. Okay, set up and track, monitor what are our service lines that have lead in them, and then of course improving communication with customers was another aspect of this lead and copper rule revision. Okay, so I'm going to switch gears from lead and talk about this Legionnaire's disease. Tell you a little bit more about that, the controversies that followed. Legionella is a bacteria. Mentioned it already. So microscope image of some Legionella. It's actually pretty commonly found in the environment. What we don't want is to breathe it in large quantities and get pneumonia. Turns out it can give you some bad pneumonia, and that would be called Legionnaire's disease, named after, it's actually in Michigan. A bunch of Legionnaires Club members were sickened in a particular facility where I think it was in the showers, aerosolized, and they were breathing it in. So they got quite sick. Interesting thing is, you can't actually spread it person to person, pretty much. Even if you're sneezing or whatever, I think you'd have to try really hard. Apparently, there's no evidence of person-to-person contact. Instead, it's usually something like a shower, maybe a contaminated water tower that doesn't have treatment, and you've got a lot of the bacteria growing, and then you walk by and all that aerosol spray, breathe it in. You just need a lot of bacteria straight into your lungs. I have a hard time imagining that you couldn't manage to, spread it that way. It's just not known to. So what happens in terms of disease tracking when we want to know, is there an outbreak? So here we're going to talk a little bit about kind of the surveillance of disease. You might be a little familiar with this stuff, having gone through COVID. And you might see why tracking COVID was not so possible or smart, perhaps, and why we had some issues identifying and really admitting to this Legionnaire's outbreak in a timely manner to take action for it. So when you have some illness, you've been exposed to a disease, now you're sick, and you go to a physician or hospital or some sort of care. Well, here's where you'll get a diagnosis. Usually you'll have to send off a sample to a laboratory, or maybe to a local health department that can do it, something like that. Or maybe the doctor themselves can do it. And then at any rate, you'll get that information of the diagnosis to a surveillance system, is the idea. So wherever you're learning of the sickness or the illness, if you end up with a disease that is being surveilled, something that is tracked, something that is reportable, So a reportable disease. So for example, the common cold is not reportable. The flu is not reportable. We just have so many of the cases, you're not really able to track who gave it to who, so it doesn't really make too much sense to track it. But Legionnaire's disease is reportable. Something like HIV would be reportable. Norovirus, something that's like, hey, that's pretty much going to be foodborne or something. Like if it's something that we can track, there's going to be this trigger saying, okay, it's this disease code, it's this thing. We're going to track that and try to figure out how to stop this because people are getting sick and we want to stop that. So certain diseases are reportable. Then they are reported to this, in this case, the Michigan system. Louisiana has its own systems, and they will ultimately collect that data into some actionable effort by the state health department. Now from here, in some cases, you would also be going to the CDC, because the CDC is essentially authorizing these and helping these state health departments with their functions. Okay, so in the case of Flint, we have people getting sick. There were some hospitalizations and patients at hospitals contracting legionellosis. And so what they ought to do is send for laboratory analysis, identify, okay, yes, this is Legionnaire's disease. And they really ought to also, at that stage, get the DNA so that, track the DNA of that bacteria so that it can be linked with environmental causes. That's kind of the point of doing surveillance. Okay, what caused this? Was it the switch to the Flint River water, for example? However, the local health department was not doing that. They were refusing, and I know this because I was married to somebody who was telling them that they should be doing this, and the CDC needs this information. Here's the survey you could do. Here's the piece of information you need to collect. And they were refusing to, and they basically, the local health department, Genesee County, was refusing to go through the proper channels, and they were trying to go straight to the CDC and complain about the situation. Like, they just didn't like them, they didn't trust them, something. They were not behaving particularly maturely, which was apparently quite sad because there used to be a really great health office there, from what I heard. So, kind of a silly, crazy situation, but they were missing that piece, which the local health department could have, at this stage, administered DNA tests from, at the patients that were being cared for in the hospital, or told them to do that so that they would have that information and then pass it along, right? So that's the way that things should have happened, but they weren't. They weren't doing that. And the reason they should have been doing that was because if you take a look at Legionellosis cases starting in 2010, we typically get a few per year. It's a little bit more common in the summer. So we see 2011, okay, we had 2, maybe even 3 cases per month sometimes. But, aside from a typical occasional case in the summer, and these would only be the cases that came to the hospital and got a diagnosis and all that. Right? If I got it today and I got sick, I don't know, maybe I cancel class and I tough it out and I'm okay because I'm young and healthy. Maybe I have to go to the hospital or the clinic because I'm really sick, get antibiotics. At that point, they would get it. But if I didn't go and I was able to tough it out, okay, no one knows. We had more cases, so these are just the cases that are reported. Well, in 2014, sometime around April, May timeframe, something happens, and now we have a pretty big spike. And it turns out the following summer in 2015, another one. I wonder why. So that coincides quite well, if you recall, with the Flint water crisis drama, right? With the change of the water. And that's quite apparent that something happened, right? So to figure out what happened, there were some studies, and There's a bunch of data, these epidemiological curves showing 2014 and 2015. And what they've done here is they have different boxes. So the color, the red, is exposure to hospital A. Now, there was some controversy with hospital A because it turns out that the high-ups at hospital A, which I'll name in a moment because it's funny, were buddy-buddy with high-ups at the Michigan Department of Health and told them, do not tell anybody. So literally, my ex had firsthand knowledge that McLaren Hospital, who of course we weren't supposed to name here, was essentially corrupt and telling people not to advertise or to let this information out, but their hospital system was sickening people, very likely. So they were part of the problem. Most hospitals have their own water treatment system to keep things like this from happening because they have a lot of vulnerable people. So there's certain protocols to do an excess wash, chlorine, like doing a major chlorine treatment events, like spiking it so that it's blasts out anything bad in there. And they weren't doing their control systems properly, and so when they had the Flint River water come in with extra bacteria, with corrosion situation, disruptive event having the Flint water come in, now suddenly their system was not going okay. So the other bars here, the gray bars, is none, at least not to the patient's knowledge. So no exposure to hospital A, and not a resident. So the blue is residents of the Flint River water. So you see a lot of people had Flint River water exposure. A lot of people had hospital exposure. Some people had neither. Maybe they have their own private well. They're getting sick. So maybe the gray ones are what would have happened normally, or maybe there's some other exposures that were also associated. That's a little hard to tell. These lines here are those added chlorine dosing. So let's see. Arrows represent the dates of Legionella control interventions in the plumbing system. So hyperchlorination in solid, superheating and hyperchloration in the dotted. So that's what they were doing to try to control it. So once they properly controlled it, I think they did get it in hand, but it was somewhere around this time frame, while the things were going on, that I remember hearing about the drama of the higher-ups. Yeah.
So like the hospital was purposefully keeping the Legionellosis cases like away from being documented?
Yeah, they didn't want the public knowing about it, basically. And so they were telling the Michigan Department of Health and Human Services to maybe not talk about that. Or I don't remember exactly, but they were trying to avoid accountability, essentially. Yeah. So another look at kind of the same sort of data. If we look at, this would be January 2014 here, and I think this is the 3 months, so that would be April, September, and so on. We have hyperchlorination here, and then hyperchlorination with superheating here, and then they finally installed a monochloramine unit to keep a little more residual chloramine in there for that part. So, and you can see this is average concentration of bacteria per liter. So yeah, they had a crisis, Flint water crisis of their own over there. Partly the hospital, probably also partly the distribution system in general. So it's probably not appropriate to attribute the entire crisis or the outbreak to the hospital, but certainly they were known to be involved, and they were eventually outed and published properly. Probably in this article. Don't quite remember. But overall, I mean, it is a little difficult to assign. So the process of trying to assign who's responsible to where is the sickness coming from, this is the type of data that you would collect as an epidemiologist. So you'd say, okay, how many people are sick? Total, and it equals 45. So we've got 45 people in the snapshot from 2015. How many of them were on City of Flint water? Well, 21, that's 47% of the 45. How many on the City of Flint Township? Okay, we've got some number. How many on other municipal water systems? Maybe they're living in Detroit and just happen to be in the hospital here or whatever. How many on private wells? And then, importantly, how many are unknown, right? And how do you categorize that? How do you figure that out? People, maybe they don't know where their water's coming from. You know, a lot of people would, but maybe some people don't, right? And so how do you go from a survey where you have incomplete data and translate that into a causal type of relationship? That's a tough task, and we can only ever really get approximations. And if the signal's strong enough, we can be like, okay, this exposure is probably an issue, and then deal with it. So you can see the table on the bottom. There's another aspect where we could do, have you had any healthcare exposure? Have you been in a hospital? Or have you not? And look at it that way. So there's so that's kind of how the data up here, kind of how you build that type of data, is looking at it that way. Okay, last slide here. We have the blue is no known hospital A exposure, and the green is hospital A exposure. So you can see that why I'm saying it's very likely that hospital A was at least part of the problem. Now, it's also true that this is only became a big problem when the Flint River water switched, right? We saw the data from the previous years. There wasn't a bunch of Legionellosis anywhere. So there's a combination of hospital A's managing their water system, highlights the importance of that, and the fact that Flint River water disrupted things. Any other questions before we go? Do you enjoy this? Okay. Feeling a little old that it's 11 years ago now, but it's just how life goes. All right. We'll see you on Thursday.